There are a wide variety of controller boards that we can use for our hardware projects. The two most popular among them are Arduino and Raspberry Pi. Today we are going to learn about the differences between the Arduino and Raspberry Pi. So without further ado, let's just jump into our topic. Arduino is based upon the Atmega family and has a relatively simple design and software structure, whereas Raspberry Pi basically is a single board, low cost, and a high performance computer. But which board do you really need? It isn't as simple which one is the best, cheapest, or most powerful. To help you decide, we have compared the two boards based on several important criteria: performance, power requirements, GPIO comparison, add-ons, cost, and programming language support. The Raspberry Pi has many different models, all powered by an ARM CPU, from the original single-core 7 MHz model in 2012 to the quad-core 1.5 GHz model as of now. The Arduino models are typically powered by Atmel microcontrollers and are often less than 100 MHz. For example, the Arduino Uno runs at 16 MHz. These chips are considerably slower and have less functionality than the chips found in the Raspberry Pi. For sheer CPU power, the Raspberry Pi was always the clear winner. Arduino's Sportena H7 is a powerful board, but it cannot match the Pi in power. Coming to the main part, if we ran a test based on pure horsepower, then the Raspberry Pi would clearly win. When it comes to power consumption, the Raspberry Pi 4 is quite a hungry board. With the Raspberry Pi 4, there was a new USB-C connector and a high-rated official power supply unit, providing up to 3 amps for the Pi and any devices connected to it. So a Raspberry Pi 4 could theoretically run up to 15 watts, and Arduino Uno can pull a maximum of 500 milliamps via USB. It can draw more current if used. In the case of power consumption, Arduino has an upper hand. General purpose input-output pins are connections to the brain of the board, and with them, code can be used to interact with the world around us. GPIO pins are two-way communication. They can be inputs or outputs, and they can use specialist communication protocols. The GPIO of Raspberry Pi consists of 40 pins, and the pins are a mixture of digital pulse width modulation and special protocols. The Arduino Uno has fewer GPIO pins, but it has the basic pins such as digital pins, PWM, I2C, SPI. The Arduino has something which the Raspberry Pi doesn't: analog inputs. These analog inputs use a constant signal, typically a voltage, as a means to communicate data. The Arduino has everything we need to start with electronics projects, including analog inputs. Arduino seems to win this comparison test because of the extra analog pins it has. The Arduino and Raspberry Pi communities have a vast selection of first and third-party accessories. Common add-ons for the Raspberry Pi are HATs, hardware attached on top, and mini HATs, sometimes referred to as PHATs, which connect to the GPIO pins. Arduino compatible boards are called as shields, and they fit top Arduino similar to HATs. But who's got the upper hand here? Now, it completely depends upon the market. The Raspberry Pi accessory market dwarfs that of any other board. Third-party manufacturers such as Pimoroni, Fortronics, Seed have fulfilled the needs and desires of learners and makers. The cheapest Raspberry Pi is the Zero W, which retails for $10 and provides a complete Linux computer with Wi-Fi and Bluetooth and access to important GPIOs. The most expensive Raspberry Pi is Pi 48GB, which retails for $75. But to get the most out of this board, you will need to purchase extra accessories and HAT boards. The cost of an Arduino can vary from just a few dollars for a clone board to almost $100 for an official Sportena H7. Arduino is a clear winner for the lowest cost of board. The Raspberry Pi is a full Linux desktop computer which just happens to have access to the GPIO. Connecting the Raspberry Pi to a monitor, keyboard, and a mouse provides us with a user experience not too far removed from a typical computer. Because the Raspberry Pi pins runs Linux, it has access to many different programming languages. Python and Scratch are two obvious examples of languages that can work with the GPIO, but there are many others including Node-RED, Ruby, and C. With the Arduino, our choice is somewhat more limited. The Arduino IDE is merely a set of C or C++ functions which are compiled and flashed to a board. Arduino boards are designed to be connected to and programmed by another computer running the IDE. In terms of flexibility, Raspberry Pi is clearly the winner. If you are getting started in single board computing or looking for a platform to learn, there is a clear choice: Raspberry Pi. Flexibility of the Raspberry Pi lies in the choice of software programming languages, and access to add-on boards, which enhances your project. On the other hand, there are projects where an Arduino board makes more sense because it's more affordable, had better analog to digital built-in, and can perform a single task right away at boot. Thanks for watching our video. Do hit the like and share button if you like the video, and don't forget to subscribe.